Hi again. So yesterday you worked out a problem, hypothetically, talking about sandwiches and like bread and ham and cheese and how we figure out how much we've got. And I'm pretty sure you guys got through this just fine. So we have a recipe, for lack of a better term, for a ham sandwich. It's going to take us 2 slices of bread, 4 slices of ham, and a slice of cheese. And then I told you how much stuff you've got. And you guys are all smart enough and you can figure this out. If I need 2 slices of bread each sandwich and I have 6 slices of bread, I should be able to get 3 sandwiches out of that. And well, if I had 24 slices of ham and I need 4, well, I'm going to get 6 sandwiches out of that and I can get 4 sandwiches out of my cheese. And so the question is, how many sandwiches can I make? And we can all logically figure out that, frankly, you're only going to get 3 sandwiches, because even though you have 6 sandwiches worth of ham, it doesn't matter because you don't have any bread to put that ham on. And so this is how many sandwiches we're really going to get. Okay, we call the bread here a limiting reagent, which I gave you a definition for that yesterday. Limiting, okay. Okay, the word reagent is just a fancy word for reactant. So if this word confuses you, you can just replace it with reactant sometimes. Our bread is going to be our limiting reagent because we run out of it first. And therefore, the number of sandwiches that the bread makes is how many sandwiches you can actually get. So how does this apply when we're actually looking at chemicals? How do we solve these problems when we're truly talking about chemicals? Let's look at it this way. If I have this reaction and I want to know what volume of water vapor at STP will be produced if 10 grams of hydrogen react with 10 grams of oxygen, well, you'll notice first off that I give you 2 numbers. In the past, when I've asked you to solve these problems, I give you 1 number and you put it on the top of the division bar and we go from there. But now we have 2 numbers, so what do? Well, basically the same thing we did with the sandwiches. I give you 2 numbers to work with. You have to work with both of them, but one at a time. So like we did with the sandwiches, where we figured out how many sandwiches we could get out of each ingredient, we're going to figure out what volume of water vapor we can get out of each ingredient, and then simply go with the one that makes the least. So I say I have 10 grams of hydrogen. I'm going to round off my molar masses for the sake of simplicity here. Happy faces. Okay. I want to put grams of hydrogen on the bottom. And because it's H2 and the molar mass of hydrogen is approximately 1 times this 2, we're going to have about a mass of 2 grams of hydrogen in 1 mole hydrogen. Now I want to emphasize this point because a couple of us are making this mistake. The mass of 1 mole of hydrogen is going to be 2 grams. Okay, I know there's a 2 here, but we accounted for that here. So we're still talking about 1 mole of this substance has a mass of 2 grams. Okay, then we're going to move our moles of hydrogen here. Okay, and this is where we want to go through our molar ratio. We want to change over to volume of water vapor. So we come up here. We go from moles of hydrogen. There are 2 because there's a 2 in front of the hydrogen here. Okay, to 2 moles of water. And then what am I asked for? I'm looking for volume of water at STP. So 1 mole of water is going to have a volume of 22.4 liters. Okay, now today I was smart enough to bring over my calculator. Push that up a little so you can see it. So what are we going to do? We're going to push 10 grams of hydrogen. I like to go left to right, divided by the 2 here. I could multiply by 2 and then divide by 2, but I'm going to mentally cancel those. Okay, times 22.4 liters will give me 112 liters oops, of H2O. Yep, squish that in that end. Okay. So we know that's how much the hydrogen would make, but what about the oxygen? So we do it again. 10 grams O2 The molar mass of oxygen is going to be 32 grams, approximately. O2, because each of them have a mass of 16 times 2, in 1 mole of oxygen. Okay, and then we go up to our reaction. Our reaction has 1 mole of oxygen for every 2 moles of water. Okay, and then we want, again, the volume of the water vapor. So 1 mole of water will have a volume of 22.4 liters of water. Okay, again, here's our calculator. 10 grams divided by 32 grams times the 2 moles times 22.4 liters, and we get 14 liters. Okay. So what volume of water vapor is going to be produced? Well, the hydrogen can make 112 liters, but after we get to 14 of those, we've run out of oxygen, and there's no more oxygen left to continue making water vapor, just like there was no bread left to continue making sandwiches. So the answer to the question is 14 liters of water vapor, okay? Because you're not going to get any more after you run out of this oxygen. You would need significantly more than that. What is our limiting reagent? Which I didn't ask for in the question, I recognize, but okay, in this case, our limiting reagent is the oxygen. Limiting reagent will always be a reactant, one of the things that you start with. It's which of these did you run out of first? Okay, and then how much of the product should you actually get? One more quick review through this. You'll be able to identify these problems as limiting reagent problems because you'll have 2 values that are both reactants. I'll give you a value for each reactant that we have. You take each of them and you calculate the amount of product that you should get. Okay, and then your answer is going to be the smaller value because you'll run out of that reactant first, and that's the most product that you can get. Just like we could have gotten 6 sandwiches worth of with the ham, but it didn't matter because we ran out of bread after 3 sandwiches. Okay, and then when I asked for the limiting reagent, that's the reactant, the thing that ran out first. Okay, so I'm going to type up some of this stuff as notes, and so that it's written out for you. You don't have to constantly come back and watch this video. And then there'll be a worksheet for you to practice this. All right, best of luck. Bye.